Hi, good morning everyone. Today, second year topic. In that second year, the first topic is electric charges and fields. You are aware of the term electric charges, right? So, this electric charges and fields usually comes under electromagnetism branch. In electromagnetism branch, we have again two categories over there. One is electrostatics and another one is electrodynamics. So what do you mean by electrostatics? When the charges is at rest, to study that branch, when the charges is in rest, if you want to study regarding the charges when they are in rest, that comes under electrostatics. When the charges in motion, if you want to study regarding the charges when they are in motion, that comes under electrodynamics. So now coming to the topic, charge. So what do you mean by charge? Very simple. It is an intrinsic property of elementary particle of matter which gives rise to electric force between various objects. So charge is basic for the to get a various force. It generates electric force between various objects. It is generally denoted with Q. Its symbol is Q, and the charge SI unit is coulomb, and it is a scalar quantity. You know what is scalar quantity and vector quantity. Yes, scalar quantity is a quantity which has only magnitude, but vector quantity, it has both magnitude and direction. Coming to properties of charges. So now you are clear with the term charge, right? It is an intrinsic property of elementary particles of matter which gives rise to electric force between various objects. It is denoted with Q, and its SI unit is coulomb, and it is a scalar quantity which has only magnitude, not specified direction. Right? Coming to properties of charges. We have two kinds of charges. They are positive charge and as well as a negative charge, right? So like charges repel each other, unlike charges attract each other. For example, if you keep two similar charges, suppose I'll take positive and positive charge, I'll place these two together beside each other. So what happens? Repulsion will arise. If I take two negative charges and keep together beside of each other one another, then what happens? Repulsion occurs. If two unlike charges, suppose positive charge and negative charge, or else negative charge beside that positive charge, if I keep, attraction will arise. So that's the meaning of this. Like charges repel each other, unlike charges attract each other. Then conservation of charge. Charge conservation. You might have heard that conservation of charge means charges cannot be created and it cannot be destroyed. Only charges can be transferred from one object to another object. So total charges are conserved, right? So conservation of charge, it cannot be neither be created nor be destroyed. Only transfer of charge is possible. It means total charge of an isolated system is constant. Isolated means which cannot exchange with the surroundings. Isolated system is it cannot exchange its charges with surrounding. So total charge of an isolated system is constant. For example, I'll take system A. Okay, in that system A, I have taken three different charges: plus 7 coulomb, plus 8 coulomb, plus 6 coulomb. Suppose on this is the charge 1, Q1, this is Q2, charge 2, and this is charge 3, Q3 in system A. So what I'll do, system A completely, I'll shake it, I'll disturb completely. Then what happens? Recombination of exchange of charges takes place. Then I'll name it as system A dash. Now what happens? The charges transferred from one object to another object. Then new charges are formed here: plus 10 coulomb, plus 12 coulomb, and third one is we don't know. Now first charge is q1, second charge is q2 dash, this is first charge is q1 dash, third charge q3 dash we don't know. Then I said total charge of an isolated system is constant. Then equate system A with the system A dash. Therefore q1 plus q2 plus q3 is equal to q1 dash plus q2 dash plus q3 dash. Now see, 7 coulomb plus 7 coulomb plus 8 coulomb plus 6 coulomb plus 7 plus 8 plus 6 is equal to plus 10 coulomb plus 12 coulomb plus q3 dash we don't know. Now this side, 7 plus 8 plus 6 21, 10 plus 12 22 plus q3 dash. Then minus q3 dash, if you take this side, then 22 minus 1, it becomes q3 dash is equal to minus 1 coulomb. So by applying this, total charge of an isolated system is constant. By taking this statement, and if you apply for the systems, then what happened? If we don't know the third charge, then we can equate the system A with the system A dash and we can calculate the third charge, right? Coming to quantization of charge. So quantization means what? Available in a fixed number, constant number, just like 1 2 3 4 and so on, not like half charge or 1/3 of a charge, 1/4 of a charge, like that. We cannot say charge is present, half charge is present, or 1/3 of a charge is present. We should not say like that. So we have to say like numbers 1 2 3 4 and so on, like that. So the smallest charge that can exist independently on charge is 1 electron. So 1 electron can, a smallest charge that appears on the charge, that is 1 electron. So we have 1 electron value 1.6 into 10 raised to minus 19 coulomb. It is constant, right? Then charge always exists in integral multiple of fundamental charge. Integral multiple means like numbers and integers like 1 2 3 4 and so on, like that, till n number of charges. So what we can say, q is equal to plus or minus ne, like this, plus 1 electron, plus 2 electron, or plus 3 electron and so on, till plus ne, n number of electrons. Or in negative sign, if you take negative charges, minus 1 electron, minus 2 electron, minus 3 electron and so on, till minus ne electrons, where n is an integer, e is charge of the electron, that is 1.6 into 10 raised to minus 19 coulomb, and q is the charge here, right? So now you just understood, right? Q is equal to plus or minus ne, that's called as a quantization of charge. Some more properties. Charges always resides on the outer surface of conductor. It accumulates more at the sharp edges. Suppose if a body is present wherever sharp edge is there, so at that surface accumulation of the charges will be more. Charge remains unaffected by motion. So it does not depend on a speed. We can see that charge remains unaffected by motion. So whereas mass depends on, like when rest mass, when the body is in rest, so mass is different. When the object is in motion, moving object has a different mass. So that is given by E is equal to mc square. That is, we will talk about that. But here charge remains unaffected by motion. It means it does not depend on a speed. So but mass depends on speed. So here Einstein has given like E is equal to mc square, right? On that basis here he has given one equation, m is equal to m naught by root of 1 minus v square minus c square. Means this is mass of the object, this is m naught is rest mass, and v square is speed, c square is light of a speed. When a person is moving, then his mass increases. When the person is in motion, usually the mass increases. When person is standing, mass is different from when he is moving. Your speed always less than light speed, right? Mass depends on speed, but charge does not depend on speed. Just now I said, whenever a object is in motion, its mass increases. When it is in rest position, rest mass mass is different, and moving mass of an object is different. So when you are moving or when the objects are moving, usually mass increases. When object is in rest or you are in rest, then the mass usually decreased as compared to the moving object mass. It means it depends on the speed, but charge does not depend on a speed. So quantization rule, you know, right? So quantization means integral number, like 1, 2, 3, 4, like that electrons are present, not half electron, 1/3 electron, like that. So according to quantization rule, charge is equal to plus or minus Ne, where Q is the charge, N is an integer, 1, 2, 3, 4, and so on. E is charge of the electron, that is 1.6 into 10 to the power of minus 19 C. And coming to next property, charge is additive in nature. So what do you mean by additive? So as usual, how we will add the numbers in algebra, like in mathematics. So we have to add the charges in the same way. So charge is additive in nature means that the total charge of a system is the algebraic sum of all the individual charges located at different points inside the system. Example, system A. Suppose number of charges are present. Now, what is the total charge on this? Then I have to add all these charges. Q is equal to Q1 plus Q2 plus Q3 and so on till Qn. Example, plus 2 mu c minus 3 mu c plus 4 mu c minus 5 mu c. These charges are present. Then what is the total charge? Q is equal to Q1 plus Q2 plus Q3 plus Q4. If I write so, plus 2 plus of minus 3 plus 4 plus of minus 5, then what happens here? Plus 2, this is plus 4, this is minus 3, and this is minus 5. So here plus 6 minus 8. So Q is equal to minus 2 mu c, like this. This is the meaning of charge is additive in nature. As usual, in algebra, under mathematics, how we will add the charges, how we will add the numbers. So in the same way, we can add the charges located at different points inside the system. Next is electrification. Then what do you mean by electrification? Electrification means charging. Body gains or loses electrons and hence gets charged. In this electrification process or charging process, what happens? Either body gains or loses electrons and hence gets charged. So here we have different types of electrification. So methods of electrification or charging. First one is charging by conduction or direct method. This is called as a direct method. See, when two neutral bodies are kept each other. Suppose you just take one neutral body. What do you mean by neutral body? Which has the same positive charges, equal number of positive and negative charges. So you just bring a charged body near to it. Negatively charged body, you just bring near of it. It is a neutral body because it has equal number of positive and equal number of negative charges. I took another charged body which is having excess of electrons. So it is a negative charged body. I kept nearer to this. So due to conduction, what happens? The recombination of charges takes place. So here this body gets extra additional electrons here, next extra charges here. So it becomes charged. Neutral body becomes charged. Even this also becomes charged. See, if a body is placed in contact with an uncharged conductor, charges flows from charged body to neutral body, right? This is a charged one and this is a neutral one. Here both got the charges, right? If shape, size, material of both conductor is same, only when the size and shape must be correct, and they must be made of same material. In that case only this conduction takes place, right? Therefore, charge acquired by neutral body is same as that of conductor. See, this is a negative charged body. Then, which charges neutral body gained? Electrons. It gains electron because negative charges are excess in this. So, it got negative charges only. That is the meaning of this. Charge acquired by the neutral body as same as that of conductor. Coming for the second process, that is charging by induction without contact. Here this is in, those are in contact, but here without contact. So what you need to do here two neutral bodies you have to take. You understood, right? Neutral body means what? Equal number of positive and equal number of negative charges. Take A and B, two neutral conductors. Okay, then just keep beside of one another. Okay, what happens? This process takes place. So recombination of charges takes place. Then separate A and B. Okay, one body gets completely positive charges, excess of positive charges. If it loses electrons to another body, obviously it gets a positive charge, which gains electrons, so it gets negatively charged body. Then bring a negatively charged body near a positively charged object. Here A is a positively charged object. Then bring a negatively charged body near the positively charged body. Then what happens? This negatively charged body attracts A, induction takes place. So usually this is a negative charges and it has the positive charges. Then what happens? These negative charges attracts this positive charges. It means this negative charged body attracts this A. Then what happens? Induction takes place, right? Charging by induction. In the third process, similarly for positively charged body with neutral body. Here what you need to do? Neutral body, equal number of electrons and protons. Right, here see negative charges and positive charges are equal. Then bring positively charged body near this neutral body. Bring positively charged body near neutral body. This positive charges attracts negative charges in neutral body, right? This positive charges attracts this negative charges. Then only here positive charges are present. So by taking one excess wire, this must be connected for a earthing. So here from the earth is just like it is having excess of electrons. So what happens here for the neutral body, the electrons comes in this way for the neutral body because it loses electrons here for another positively charged body. Then only here positive charges are present. So then what happens? From the earth here, negative charges, again these positive charges attracts this electrons like this, right? Coming for charging by friction, occurs in insulators. This charging by friction occurs in insulators. Suppose rubbing of a hand, just take your two hands and just rub your hands together. Then what happens? Before, when you are not rubbing your hands, if you observe, it is in a normal temperature. When you rub together, what happens? You will feel heat, right? So what happened there? There is an exchange of charges in between your hands. So one hand will get excess of negative charges and one hand will get excess of positive charges. Recombination of charges takes place. Due to this, what happens? Kinetic energy will be produced in between the friction process. So here what happens? Energy is developed, heat energy, or we can say thermal energy is developed. So transfer of charge takes place here, right? Before it was equal number of positive and negative charges. It is also equal number of positive and negative charges. When you rub two hands together, recombination of charges takes place. Then kinetic energy is produced, and due to that thermal energy is generated. I can say heat energy is generated. So here when two bodies are rubbed against each other, one body loses electrons to the other, thus they get opposite charges, right? Here when it loses electrons, it gets a positive charge. When it gains electrons, it gets a negative charge. So because of the difference in their electronic affinities. So this is friction process. When two neutral bodies rub each other, then charges, one body loses charges, it gains a positive charge, which gains the charges, negative charges, it gets negative charge. Due to this, kinetic energy is produced. Due to this kinetic energy, thermal energy or heat energy is produced. And here charges, transfer of charges takes place. So why this process occurs? Because of their difference in their electron affinities, right? So now you understood charges and types of charges and process of electrification. Now coming to Coulomb's law. Like in the year of 1785, French physicist Charles Augustin Coulomb has given this famous law. So according to this law, the electrostatic force of attraction or repulsion between any two point charges is directly proportional to product of the magnitudes of the charges and inversely proportional to the square of the distance between them, and it acts along the line joining the center of two charges. Means just observe this diagram, two charges you have to consider. So here just now I said when two similar charges are there, repulsion will take place. If unlike charges are there, attraction will takes place. So here the electrostatic force of attraction or repulsion between any two charges is directly proportional to product of their magnitude of the charges. So product of these two charges, it is directly, the force is directly proportional to product of their charges and inversely proportional to square of the distance between these two charges. Here distance of separation we have taken as a r, and charge 1 is taken as a q1 and another charge is taken as a q2. So this q2 exerts force on q1, similarly this q1 exerts force on q2. So F21 means what? The force exerted by the first body on the second, and this is F12 means what? Force exerted by the first object, second object on the first object. So I can say the force of attraction or repulsion between two charges is directly proportional to product of the magnitudes of the charges is inversely product of the magnitudes of the charges, directly proportional, right? And inversely proportional to the square of the distance between them, and it acts along the line joining the center of two charges, line joining the center of the two charges. I can say from this diagram F is directly proportional to Q1 and Q2. I can write here F is proportional to Q1, Q2, and similarly distance of separation is r, so inversely proportional to square of the distance. F is proportional to 1 by r square. Now combining these two, F is proportional to Q1, Q2 by r square. To remove this proportionality constant, we have to introduce constant term. Here constant term is k. K into F is equal to k into Q1, Q2 by r square. But k value is a constant, that is equal to 1 divided by 4 pi epsilon naught. Epsilon naught means what here? Permittivity, right? Epsilon naught is permittivity. What is r here in this equation? Distance of separation of two charges. Q1 and Q2, two charges. And here F depends on a medium also. So only epsilon naught we have taken, right? Permittivity. So we will continue in the next class. Thank you.